Awesome. Thank you so much for, I think, coming very early in the morning. I think a lot of you partying yesterday night and maybe showing up is a bit hard. So today we will be talking about, as Mike said, I think a Spotter. It's an open source tool. Actually, we are releasing this year, primarily at DEF CON as well as in the Black Hat. So a bit about Spotter. So I'm sure if you have been using Kubernetes, you come across policy engines, security scanners, and other thing. So how many of you use Kubernetes in production? That's quite a lot. Of course, I expect at least this is a cloud security village, right? So how many of you do like security work rather than platform or engineering or developer work? Mostly security people. Of course, security conference, right? So this tool trying to help and bridge the gap between the security engineering as well as the engineers who works on day in and day out between like platform, SRE or whatever the thing, to use something like unified policies. So once you write the policy, you can able to use them maybe in the CLI, manifest, Helm charts, or CI/CD, or even admission controller, right? As I think I can skip this slide most probably. I've been pretty much working on Kubernetes security for almost a while, since 2017. Started presenting most of my research at a couple of conferences like Black Hat, DEF CON, Usenix, and a couple of them. We actually open sourced a while ago a project called Kubernetes Goat, if you're aware about it. It's a basically open source playground to learn and hack Kubernetes clusters. So this tool is kind of to cover the other side of the vertical, where you can bridge the gap between engineering and security, fix those security issues, and in a policy way, right? Yeah, maybe I'll just give some kind of context before we start explaining the tool and what it does and stuff. So why really Kubernetes security matters, right? If you are someone coming from security background, it's super hard to catch up with the Kubernetes speed, right? Every year they release 4 releases, like maybe I think they recently changed it to 3. So by the time you deployed like 1.32 version of Kubernetes, they might have changed something in 1.33, right? Leave about security, even engineers hard to catch up with what's happening within the Kubernetes space, right? So this is just to showcase like if your cluster is got hacked, they just go and delete the pod. The whole point of Kubernetes is it's not going to fix that, right? You just spin up automatically another pod. Even if you delete the node, it will auto scale and spin up a new node. So it doesn't kind of fix security issues. The way we work in traditional environment, it kind of changes the way how Kubernetes operates and manage security, right? And as I said, it's a super rapidly growing, and I'm sure if you ever looked at, or if you want to go back and look at, there is a website called landscape.cncf.io, which is a lot of the all cloud native foundation projects get hosted by them. Without you knowing, most probably in your organization, using at least 4 to 10 of these projects in your company, right? Kubernetes is just a tiny piece, most probably sitting here, that's all. So these all are the projects which is underlying may or may not be using by Kubernetes as well as other teams within the engineering, right? So it's super growing. So we wanted to make sure bridge this gap and understand security to catch the speed, right? One of the biggest thing is if you don't understand the technology, you can't fix the security, right? Which means you are just blindly following some vendor tools or maybe someone else tool results or like some scanner outputs. So which is not going to help you to prevent security issues, right? So if you look at the industry, there is ton of attacks happens in day in and day out, coming from simple supply chain attacks which compromise image to cluster takeover, to maybe someone doing cryptojacking and mining your cluster resources, right? So we may or may not be able to fix everything. So it's super hard also to combine, okay, I'll fix this Kubernetes security, so it should be all good. Because most of the people think in Kubernetes security is something called layered architecture, right? Maybe you wanted to fix maybe Kubernetes or infrastructure, but the vulnerability can come from maybe supply chain, right? The supply chain can start introducing some backdoor image that can give an internal access to the cluster. From there, they maybe do privilege escalation, laterally move, and all the things, right? So you cannot just fix one layer and see, okay, we are all secure in this layer, right? So that is a bit hard problem to solve, and also given this is so rapidly bigger ecosystem, right? So that's where most people, sorry, I wanted to take for cool. So that's why we wanted to learn Kubernetes security, right? Like how do we do this, and how can I learn like what kind of these security risks and stuff. So if you really want to learn Kubernetes security, so there is a really interesting project called Kubernetes Goat, which is a completely open source and used by quite a lot of security researchers and detection engineering teams. including the product vendors, interestingly, right? A lot of companies like Microsoft Defender, Palo Alto, Upticks, and a couple of people use them to see if their products really working or not, right? So this has extremely well documented scenarios, almost like 22 scenarios ranging from simple basic attacks to cluster takeovers, and detection engineering like Falco, eBPF, Tetragon, or maybe policy engines like Kyverno and other stuff. So this would be an amazing place if you would love to learn Kubernetes security and try it out yourself, right? And yeah, there is a lot of love from the community as well. So what about if you want to fix them, right? That's where we wanted to introduce Spotter. I will quickly give what exactly Spotter does, then we will most probably try to spend most of the time in the hands-on than the slides, given this is a tool demo talk, right? So Spotter is a very high-level, simple architecture. So we kind of wanted to focus on something called a configuration layer, which is one of the key part. So if you see Spotter, most of the rules are designed based on the ML, same like Kubernetes, right? Or most of the IAC, infrastructure as a code stuff. We wanted to define this ML rule where it basically prevent a lot of security rules once you define them in a spec format. And we use something called cell, which is the common expression language. If you are someone using Kubernetes, now it's natively integrated into validation admission controller, which means you can reuse the same rules without using the tool natively in the clusters as well, right? And if you come across a lot of security vendors or open source tool, most of them using something called OPA, Open Policy Agent or Rego, which gets complex over the time. And also it's very difficult to adjust the rules and flexibility wise and things. So that's where we have put another extra feature in the Kubernetes Spotter. So that is basically the rule engine. So you have extremely extensible flexibility. So you can also say, okay, I don't want to scan these namespaces or these resources. Maybe you can add extra labels and custom resources. So you can able to exclude these things within the rules and able to customly scan entire your clusters, right? Of course, we have different types of output formats like JSON, table format, Sarif, so that you can able to integrate with your favorite CI/CD tools or vulnerability or whatever the commercial management reporting vendors as well, right? I think we call Spotter as a comprehensive Kubernetes security scanner, and it does a couple of things. It can able to detect misconfigurations and most probably vulnerabilities or any compliance issues, especially mapping back to standards like CIS, NIST, or NSA hardening guidelines, or maybe whatever the compliance you wanted to map it back and write them, right? As I said, we will be using cell, so I'll quickly go through a couple of them when we are doing demo. So we basically focus on something called security rule evaluation, which means once you create a one rule, it should be able to reusable across the lifecycle of Kubernetes, right? Currently, Spotter covers various categories of security issues, like ranging from workload security to access control, network traffic, or maybe configuration and resource hygiene towards still runtime and platform security, right? So currently, it holds approximately 140 plus rules, the Spotter superpowers. So it can able to basically use a couple of industry tools as well, like Kix, Kubescape, and other vendor tools as well, and open source as well. We kind of consolidated these 140 rules so that people can able to scan them and reuse those rules. So these by default baked into your binary. When you download the Spotter, you should be able to get all these 140 rules by default built in. So we can also able to do different kind of scanning, like you can able to scan manifest, which is basically ML, and Helm charts and live clusters, also admission controller. So I think it's mostly where we will showcase a couple of demonstration where we can also deploy as admission controller, which means you can also say that the same rule can allow or not, do not allow to deploy into Kubernetes clusters. It's still in early stage. As you see, this is the first release. So most probably you will have a lot of issues and bugs. So please bear with the project. So it will be still growing and updating, right? The only thing which we wanted to highlight specifically tool is extensibility. So I'll quickly showcase what exactly means extensibility, right? So this is how it looks like Spotter in action. So you can able to scan the cluster or manifest, so it can give you enhanced output. Of course, you cannot read this output from back. I'll be just showcasing the CLI. But what we are trying to do is we kind of helping users, or like which can be security or SREs or platform, to basically make better decisions when fixing these security risks. Rather than throwing up like maybe 300 findings, okay, you have to fix them. We wanted to find like 80-20 rule, like what are the some of the 3 fixes which you wanted to do, which covers a lot of security fixes, which has high impact. Right? Something like evaluation engine we are working on. So let's start with the demo and see how we can get Spotter up and running, right? So I will try to just quickly do a couple of checks. I hope you can see my font in the back. Can you see any font issues? All good? Okay, perfect. Yes, you can able to access Spotter. This is the GitHub repository, which is yesterday, I think yesterday we have the first release, like we open source. You can able to please feel free to give it a star and try for sure. And you also have all documentation available. Website called spotter.run, the QR code which you scanned, it's most probably would have redirected here. So you should be able to find all the documentation and the command line interfaces and stuff if you want to try it out yourself. And we also wanted to showcase the last part in a bit, which is a web playground using WebAssembly. So you can not only use this across the lifecycle, we also built a WASM playground, which you can try it out right from the browser, right? So let me go ahead and start. So I already have Spotter locally built. So this is how it looks like, a very high level simple overview of how Spotter looks like. So let's start with the scan option. So you can able to scan various things, as I said, cluster directly or Helm charts or manifest. So maybe I'll start with the manifest because this is how most of the developers or engineers deploy applications into Kubernetes. So I also said we host another project called Kubernetes Goat. Let's go back and take, if I can pick the Kubernetes Goat, a simple scenario which has already intentionally vulnerabilities, right? So that I can able to scan this against those intentional vulnerabilities. So you can able to run this. By default, it does the built-in checks, which means, as I said, we have already 140 plus built-in rules. So what it did just now is, most probably I'll try to little bit zoom out so that you can see the proper output of the fancy thing. So what it did is, it did against all the rules, 142 rules, and it kind of finds any potential security gaps based on the resources which we scanned against, right? It kind of gives based on the category, like whichever the thing, and it also gives based on the severity and the resource type. Like let's say you wanted to focus mainly on maybe pods and deployments and secrets. Maybe for you config maps is not much important. So you can able to include, exclude all of these things, by the way, right? So you can also see what are the top critical findings, high and medium. You can also go a bit more verbose. So you can give a flag called verbose. So it can give you detail what kind of things going wrong and what kind of things you wanted to fix based on the security issue it detected, right? So as I said, there are multiple output formats. So I can also print this thing in the JSON, so that you can feed back this data into maybe vulnerability management tools or maybe even SIM tools, so that you can alert something happen in your CI/CD or something. And also you can able to integrate with like Sarif and other stuff. So I just wanted to not only show this, maybe how can we scan the cluster resources. So what I have done before the demo is I just deployed the same Kubernetes Goat in a cluster. So you can see this already deployed bunch of vulnerable applications into Kubernetes cluster, which is running live, right? So I just wanted to scan directly the cluster. Like you can see ton of them, by the way. This is just some of them. I have deployed so many pods across the cluster, different namespaces, different resources. You can also see so many resources, not just pods. We have deployed a couple of them, like a couple of roles, a couple of Cilium stuff, couple of network security policies and other thing. Okay, so let's go back and quickly scan the cluster. So I can also scan Spotter with the scan option with cluster. So what it does is it basically scans the live cluster which is running there, right? So I'll go ahead and run. Maybe it just definitely takes some time because I have almost so many resources running. So I'll quickly go behind the scenes what exactly it is trying to do when we run the scans and manifest and see how the rule is working, right? I'll try to use this documentation so that it's easier for me. I hope you can see the font back, right? Okay. Yes. This is how exactly Spotter rule looks like. That is what it is trying to do the whole life cycle. So when we define Spotter, so we also can future, by the way, which is still in work in progress. You can also run it as an admission controller with in-house cluster resource, which is like custom resource stuff, right? Which means you are not even bringing this outside of Kubernetes ecosystem. So you have a couple of things. You can also define severity, which is basically mapping back to CVSS scoring. And we also have categories and industry standard mappings. So you can map it back to maybe NIST, CIS, or NSA hardening guidelines, whatnot. And this is where most of the power comes for Spotter, right? So if you look at this, this is what differentiates and adds a lot of value to engineering teams, leave about the security, right? Because we are trying to cater for them at the end of the day, right? Engineers. So if you look at this one, we try to able to customly define the rules. So we don't have like a built-in baked, okay, we only scan pods, deployments, and maybe secrets, config maps. So we also have customly define API groups. Let's say your company written your own custom resources like CRDs or operators or something. So most of the vendors like by default bake into what Kubernetes natively supports, like maybe the Cilium or Istio or whatnot. So here you can also define your own custom resources and maybe the different kind of resources which you company or organization or people have deployed. And you can also include and exclude namespaces. Let's say you keep on scanning every time, maybe there are 300 issues coming up. Maybe you don't want to give developers or engineers to fix all of them on time, right? Maybe some of them you wanted to ignore. Maybe you add it to risk registry and say that, okay, we will fix this in Q2 or Q3. So you can also add a label called spotter, something disable or like enable or some custom resource or custom labeling. So you can also define this way to exclude this from scanning, like maybe till the next quarter. And again, this rule is version control so that you know this is going to be updated whenever the QT is happening, so that you are going to scan back the all resources which they're supposed to fix as per your risk registry or whatever the things, right? And this is where you can see the cell policy. This is what I mean to say, like we use cell. This is one of the thing natively embedded into Kubernetes validation webhook, which means by default they will be using this currently, which is GA as well, generally available. So which means you don't even need to tomorrow use spotter. Maybe you don't need to rewrite entire rules which you have been using with one vendor when you are shifting to something else, because this is by default natively supports in Kubernetes. So you can able to reuse the same rules with validation webhook, and you can able to prevent these security issues with the same way, right? And of course we currently have manual. Ideally the whole idea is we want to integrate with something called KTest GPT. If you have come across, this is another open source project by CNCF Foundation, where you can integrate with whatever all LLMs or AI tools. So you can also feedback this and able to implement with KTest GPT, because it already has all the context of your Kubernetes, right? And I think I'll go back. Hopefully my scanner results should be there. Yes, there you go. So as you see, if you see here, we are trying to pretty much dynamically scan all the resources. That's why we are not specific to what Kubernetes natively does. If suppose someone built their own custom CRDs or operators, we should be able to scan with this thing, right? So you can see there are a couple of findings, because it's pretty much all of them intentionally vulnerable. That's the whole point of Kubernetes code, right? So you can see ton of these vulnerabilities and scans. And again, there is a lot of flexibility, I think, in this scanning and other options. So I'll maybe quickly give a couple of flags, of course. You can also exclude a couple of namespaces, include, and also you can only scan specific rules if you wanted to scan. And you can also define, okay, how many violations before you basically break the CI/CD pipeline or something, right? Or how many rules to be included. And you can also define basically different custom rules also. Let's say your company built your own custom rules for your use case. Maybe you cannot just pass them rather than just using built-in rules, which means you are trying to build more customization to the end users, which means let's say your company has a certain way of building Kubernetes manifest or Helm charts, because they build templatized and all. So you can able to define custom rules so that they can be automatically scanned every time, so that you don't need to keep on doing. So as I said, the same rule now we applied at manifest and cluster. So now I also can able to apply something in. I don't have time to set up entire thing. So what I did is I quickly recorded, so that given 25 minutes of the demo. So I'll quickly showcase another side of the vertical. So in this case, we wanted to use the same rule in the admission controller. Means, so if you see here, we just created a couple of certs so that we can able to deploy custom mutation webhook in the Kubernetes cluster, and we just deployed spotter as a deployment in cluster, right? So then what we are going to do is we just deployed something called validation webhook. I'll just use a quick slide or internet documentation to explain what it is doing. To this one. So if you ever looked at Kubernetes, this is how it typically happens. So if anyone sends an API request, it can be developer, even Kubernetes internal resources, maybe kubelet or other resources, they has to go through API server, right? Which means whenever it does the API request, it does authentication. Is the user or the token which is requested to make the request is allowed to make access? If they say yes, and then that is where authorization kicks in. Whatever they say, RBAC, roles, cluster roles, role bindings, they all tells that do the user is allowed to create pods or list pods or get secrets. So these all data validations happens here. Once it happens, there is something called mutation webhook. So this means you can also mutate the request, which means someone sends a request with the image equal to Docker Hub, pull the registry, they can replace with internal private registry so that they are not pulling from official registries. So a lot of vendor tools also work on here. and also a lot of security researchers work here. If someone has access to mutation webhook, technically you can able to manipulate entire cluster resources, like pretty much control the entire cluster. Then once it does validation of the changed data, then it goes to schema validation. Okay, JSON is valid, YAML is valid. Then this is where Spotter sits in, or most of your commercial security vendors or policy engines. What they do is they hook into all the thing, validate policy across this data which is coming before even schedule the workloads into Kubernetes. They either fail or allow them into it. So this is what we just deployed, right? Sorry for the long demo, so that I wanted to just build the context, right? So now we just deployed our Spotter there, and it is sitting there. What we are just validating is it up and running, ready to use? It's ready. So now what I'm going to do is I created a simple namespace called test spotter. Then now I'm going to deploy a simple pod which is completely secure. You see, it has like a admin privilege escalation is false, allow privileges, and the capabilities dropped all, and it has properly shard tag checksum. It's a completely secure manifest. So as per our rules, if there is a secure one, it should be able to create. As you see, it is already created. But now I'm going to again deploy something dummy pod which has completely insecure. And as you see, it's already failed. It is saying that Spotter has denied this because so-and-so rule has prevented this to deploy into the Kubernetes workload. So what we have just done is we kind of not only used Spotter just to scan manifests or cluster resources, we also able to scan and prevent them in the admission controller. So we kind of use the same policy across the life cycle rather than using one tool in one place, in different tool in the maybe admission controller or something, right? Maybe I don't have much time. I'll try to quickly do a couple of demos very fast. Maybe this is like a super fast track. So we also have a built-in rules. You can find in rules list. So you can see all the 142 rules here. Like you can also see them based on the severity and like by specifying the whatever the version. You can also do something called rules info. So you can also see how the rule look like. And you can also see the version of the way cell query is there on top of this rule as well. So it's pretty much baked into everything. Even you can do custom rules yourself. So we are actually working on something called the WASM, as I said. So this is going to be basically gives you a way to play around the browser as well, the same binary. So if you go back here and browse this, by the way, this is already baked into play.spotter.run. So I'm just fixing a couple of bugs. So you can also scan the same resources in the browser and able to find the security issues. You can also disable, enable custom stuff, and you can able to scan them from the browser. So we are using the single policy across the life cycle, and also we are giving a flexibility with the same binary with the WebAssembly and trying to write them and reuse them, right? So I think we are almost in time. As I said, this is one of the core power of this Spotter, and we are trying to work like a couple of things. Like one of the things is we wanted to integrate with a lot of CNCF projects, especially the sandbox, graduated, and incubation. And we also wanted to have much more integration with rules and completely open a rule registry. If you most probably go back from DEF CON, if you see rules.spotter.run, so you might see complete rules available. And we're working mainly to empower the gap between engineering teams and security team by providing this in a practical way to apply security principles, right? With that, thank you so much for joining. If you have any questions, I'll be there. Please feel free to grab a sticker. And if you have any questions, I would love to hear your feedback. Thanks.